Today we're going to learn about the line of best fit. So our essential question is, how can I find and write an equation for the line of best fit? Some vocabulary. This is already written down for you, so just listen. Scatterplot is a graph used to determine whether there is a relationship between paired data. So if you look down here, here is an example of a scatterplot. Those yellow dots just all scattered onto the graph, they kind of look like they're just a little bit thrown onto the graph. That's a scatter plot. So not all the points line up in a nice straight line, they're kind of scattered, hence the name scatter plot. Now there's this thing called the line of best fit, and that's a line that models the trend in the data, and that's this blue line here in the image. That's that line of best fit. It kind of fits right through the middle of the data. Models that trend, models what's happening. All right, so our goal today is to be able to find the line of best fit in a scatter plot and write an equation for that line. So below are the measurements of a little baby alligator by month. So each month, that's our x values, our input, gives the length, the output y, of the alligator. So we're going to start by plotting these points to make our scatter plot. So y over here, now I'm going to write length right there by y. So I remember that this side is length, and here's x. So down here I'm going to put months. So I remember that this is my months. Time. Okay? So let's plot the first point, 0, 22. So it's going to go 0, 22. Okay, second point, 1, 22.5. So we go over to 1 on our x-axis, and then we go up to 22.5, which is right in between 22 and 23. Then 2, 23.5. Well, go over to 2, go up to 23.5, right in the middle of 23 and 24. Then we have 3, 25. So 3, 25. Then 4, 26, 5, 27, 6, 28.5, and the last one, 7, 29.5. All right, so if we look at our data that we just plotted on our graph, we want to draw the line of best fit. So as I'm looking here, we kind of see this trend right through these 3 points here in the middle. If I draw a line that connects these 3 points right here in the middle, you can kind of see there's this trend, this pattern that it's following. And if you look, there are 2 points, these two right here, that are below the line, and 2 points that are above the line. So the line goes right through the middle of the data. It kind of is cutting the data in half. So now that we have our line, that's number 2. We drew the line of best fit. It's the line that just kind of slices that data right in the middle. Now we want to write an equation of this line because we want to use this to help us answer some questions about how fast the baby alligators grow. So to do so, we need to first identify 2 coordinate points on the graph. Well, let's use these 2 right here. Now we can either get the information from our graph or from our table. Either one. So I'm just going to look at the table. It's my black point and my red point, so I know it's 325 and 426. Now I want to find the slope. So I'm going to label my points x1, y1, x2, y2. We do y2 minus y1, 26 minus 25, over x2 minus x1, 4 minus 3. 26 minus 25 is 1. 25 4 minus 3 is 1. So our slope is 1. That's a nice slope. Identify the y-intercept. We look at our y-axis right here. Where do we cross the y-axis? And that'd be right here at 22. So now we want to write the equation in y equals mx plus b. So our m, that's 1. And our b is 22. So that's the equation of our line of best fit. Now, what that means is 22 means that's where we started. That's how much the baby alligator started at in length. And then 1 means that each month he's growing 1 inch, about 1 inch. So we're going to use this equation to make a prediction. Prediction. What would be the length of the baby alligator on the 12th month of measuring, the 12th month? So if I look, months, that was my x-axis. That's my x value. So right here, we're saying x equals 12. And we want to know what would that length be. So we're saying, what does y equal when x equals 12? We want to know what's that length going to be. What's our y going to be when x is 12? So we use our equation. We have our equation y equals 1x plus 22. Now we're going to take that 12 and put it in for x. So we do y equals 1 times 12 plus 22. 1 times 12 is 12 plus 22. That gives us 34 inches. That's how long that baby alligator would be on the 12th month of measuring. That would be our prediction based on the trend of the data. All right, second example. Which equation most closely represents the line of best fit for the scatterplot below? So this is multiple choice. And multiple choice, there are many ways to answer the question. If you know the answer, you can just choose the right answer. But in a case like this where we're not quite sure what that line of best fit would be, use the process of elimination. Let's graph each of these lines and see which one would actually be the line of best fit. That's all we have to do. Y equals x. So if we're thinking y equals mx plus b for graphing, we start with our b. Well, there is no b, so that's really plus 0. So that would start right here at 0. And then our slope would be the number that's in front of x, which would be a 1. So that means we're rising 1, running 1, and so forth. Now, if we look at this line right here in blue, we want our line of best fit to cut the data in half. And that didn't really go through all the data. It's kind of on the bottom half of the data. It's not really cutting through. So we can say that 1 is not correct. So now let's move on to equation of line 2. So we have y equals 2/3 x plus 1. So that plus 1 means we're starting at 1. Then 2/3 means we're rising 2, running 3. So we're going to rise 2, run 3, rise 2, run 3. Rise 2, run 3, and so forth. Now, this line is kind of like the blue line, where it doesn't go through the middle of the data. It's really down there at the bottom of the data. So we can say that 2 would not be the line of best fit. So let's try the equation of line 3. We have plus 4 for our b, so we start at 4. Then 3 over 2 says we're going to go up 3 over 2. Up 3 over 2, up 3 over 2. Graph that line. Now this line is the opposite of line 1 and 2. It's too high. It's all the way above the data. You see all this data here in the middle? It's not covering that data. So we can say that line 3 is definitely not it, which leaves us line 4. So I'm going to erase these lines here. And let's graph line 4 just to make sure it looks right. 1, that's where we start, right here at 1 on our y-axis. 3 over 2 means we go up 3 over 2, up 3 over 2, up 3 over 2. And that line cuts nicely through the middle of the data. We've got points down here below it, points up here above it. So that is for sure the line of best fit. So now we want to use that equation. The whole point of that equation is so we can use it to make these predictions. How much money would one earn after babysitting 12 hours? Well, let's look. In our graph, money right here is on the y-axis. So we're saying y is money, and the hours we babysit is on our x-axis. So hours is for x. So if we look down here, how much money? We want to know money. So y equals question mark. We don't know that. That's what we want to know. How much money would one earn after babysitting 12 hours? So hours is x, so we say x equals 12. We're using our equation, y equals 3 over 2x plus 1. So we're going to put this value in for x. Substitute 12 in. Y equals 3 over 2 times 12 plus 1. 3 over 2 times 12 is 36 over 2 plus 1. 36 divided by 2 would be 18 plus 1 would give you $19. Now, I don't know about you, but if I babysat for 12 hours, I would want a whole lot more than $19. So I don't think I would be babysitting for those people. All right, that's all the notes that I have for you today. So my instructions are to put your Chromebook away, complete the 5.6 homework. Then if you complete that and still have time left, you can take out your Chromebook and do the 5.6 IXL practice. Thank you for watching my video, and please subscribe to my YouTube channel.